Hello everyone, let's finish this work with our last section of chapter 7, selected topic of analytic trigonometry. In this last section, we just have, as you can see, we only have like 7 additional formulas to tack on to top of the list of formulas, identities, and so on that we have in this chapter. Now, the formulas we have are those that change the form of a product to sum, often called product to sum. You look at these formulas, you have sum of two trig functions, and the sum in turn is turned into a sum or difference of expressions. So it's product to sum, often called. And on the right side, we have sum to product formulas. The sum to product is just the opposite. You're given sum or difference of two trig functions, and the task is to put it together as factors, product of trig functions. So that's what these are. When do we use this? Well, the one on the left side, I have used it in calculus, so chances are you will use it, although not often, but there are certain segments, certain types of integrals that you will do in calculus where you have to change from product to sum in order to be able to integrate the problem. And the one on the right side, the sum to product formulas, these we typically use them to solve trig equations. Now, because this is a course in pre-calc, clearly we're not going to do the integration part, that's for the calculus, but we will do just a few. This is not going to be a long video, in fact probably one of the shortest videos I have about this section. We're just going to solve some basic trig equations with it. Okay, so first of all, let's start by actually, like, how do I use these formulas, right? So for this one, let's say I'm making something up here. Suppose I have an expression. Let's say this is sine 4 theta times cosine of 2 theta. So we do have a product, and we want to change this from product to sum. That's what we want to do. We want to rewrite it as sum or difference of trig functions. So how are we going to do this? Well, we're going to just make sure we have the correct product to sum formula. Involves sine and cosine. That's both sines. This is both cosines. Well, sine cosine is the last one. So I'm just going to follow the script here, the right side. Okay, my alpha, this is alpha, and this is beta in the general form. All right, so here we go. The product to sum is going to be 1/2 that of sine of the sum of two angles, as 4 theta plus 2 theta, correct, plus sine of the difference between them, 4 theta minus 2 theta. Now subtraction is not, it's not commutative, so you got to be careful which you subtract from. If you're subtracting beta from alpha, the second angle from the first, and that makes a difference. If the function is odd, which sine is, that could change the answer. Okay, and what's the last step? Well, 4 plus 2 makes 6, so this is sine of 6 theta plus sine of 2 theta, and we are done. Again, if this was, let's say, a calculus problem involving integration, now I would be able to integrate these much easier than I could do the product. Let's do an example where we go the opposite route. Now, suppose we are given a difference. For instance, suppose I have cosine theta minus 2 and cosine 3 theta minus 2. So I'm given difference. I'm going to go from sum to product now. I know it's difference, but they're usually called sum to product. I guess you can view subtraction as addition or sum with opposites, so that justifies it. Okay, however we do it. Cosine minus cosine, so this is out, out, out. We go with the last one. Okay, so it's going to be -2 sine of this sum divided by 2 and the sine of the difference divided by 2. Okay, and that's all I'm going to do. Just plug into the formula. I'm going to have -2 sine. I did mention sine of the sum divided by 2. So it's going to be theta over 2 plus 3 theta over 2, then divided by 2, right, times sine of the difference divided by 2. Okay, the difference would be theta minus 2, 3 theta minus 2, all of that divided by 2. And this is going to be -2 sine of, in the numerator of the first fraction, 3 plus 1 theta makes 4 theta divided by 2, correct? So that's 2 theta divided by 2. And the second parentheses, theta over 2 minus 3 theta over 2, that's -2 theta over 2, or just negative theta. That's negative theta divided by 2. Okay, and then we can further simplify this as 2 sine theta times, and the sine of the negative angle is going to be negative sine of the positive angle, right? So that's negative sine of theta over 2. Negative times negative is positive, so the answer to this is going to be 2 sine theta times sine theta divided by 2. And there we have this one. Okay, pretty easy. Just direct application of these formulas. And let's do just one last one. Let's say we want to solve this trig equation. Cosine 4 theta negative cosine 6 theta. Okay, and set it equal to 0. Suppose we want to solve this one. Now, in order to solve equations, remember, we have to have the factored form, right? And that's why the sum to product, right, sum to product comes in handy. This, I meant to have that for my example. Okay. So that's what a sum to product is used for. I have cosine 4 theta minus cosine 6 theta. So that would be, again, the last formula that we just did, right? So I'm going to change this to -2 sine of the sum divided by 2. That's 4 theta plus 6 theta divided by 2 times sine of the difference divided by 2, 4 theta minus 6 theta divided by 2. And now set it equal to 0. You see what this will do for us? It will give us the factored form. And this is -2 sine of 5 theta times negative sine of theta. That's because 4 theta minus 6 theta is -2 theta by 2 is negative theta. And sine of negative theta is negative sine theta, right? Due to negative angle identities. And set it equal to 0. Negative times negative is positive, so this becomes 2 sine 5 theta times sine theta equals 0. Now we can apply the zero factor property to this. If you want to divide everything by 2 and the 2 cancels. I mean, not everything, but divide both sides by 2, I should say. There, by 2, these cancel, so you still have 0. So all I need to do is set sine 5 theta equal to 0 and set sine theta equals 0. Well, sine theta equals 0, so we're looking at the zeros of sine. And suppose our solution, let's make it easy on ourselves. Suppose we want the solution in 0 to 2 pi. Okay, in that interval. Now the zeros of sine we know is k pi, right? So in 0 to 2 pi, the zeros are 0 and pi. That takes care of that one. Now for 5 theta, because it's a multiple angle, I'm going to set 5 theta equals k pi that gives me all infinite number of zeros, the x-intercepts. That would be k pi over 5. So in other words, I have pi over 5 and all multiples of pi over 5, including 0 multiple. Remember, k is integer. K is an integer. And what is an integer? Just to, from time to time, to remind you, this is a set of integers, right? There you have it. Now, if I plug in for k, let's get some numbers out of this. And remember, we want 0 to 2 pi, so I'm going to start with 0. So from this, when k is 0, I get 0. When k is 1, you get 1 pi over 5. k2, we get 2 pi. Fifth, 3 pi, 4 pi, and 5 pi over 5, which is pi, correct? This is pi. I'm just going to change that to pi. And we will continue on. 6 pi over 5, 7, 8, 9. Now 10 pi over 5 is 2 pi. And we just want to stop because we want the 0 included up to 2 pi, not including. And there we have it. Now we can make a couple of observations here. The solution that's given by one of those factors, sine theta, namely 0 and pi, are already included in this set, right? So sine 5 theta, in other words, is going to pick that up as well. Therefore, we don't need to count this twice, right? This is already included in the final answer. So this is indeed the final answer for this example. Okay, and there you have it. Again, that's probably enough because you really won't do a whole heck of a lot with sum to product, product to sums in other courses that you will be taking. All right, and this is again probably one of the shortest videos. I like to keep it that way. So thank you for watching, and with this we are done with analytic trigonometry, the long chapter that we were plowing through. Thank you for watching, everyone, and again, be safe, and hope to host you in another video. Thank you.